Hello learners, this is Habeeba with Excelwithme. If you like the video, please do like, share, subscribe and comment below. Let's start today's class, that is descriptive statistics of the paper research methodology, with the subtopic measures of variability, range, quartile deviation, standard deviation, average deviation and coefficient of variation. Let's start with measures of variability. That is, first let's understand what is variability. Variability in statistics means deviation of scores in a group of series from their mean scores. It actually refers to the spread of scores in the group in relation to the mean. It is also known as dispersion. For instance, in a group of 10 participants, we have scored differently on a mathematics test. Each individual varies from the other in terms of the marks that he or she has scored. Obviously, each student will differ in their marks. These variations can be measured with the help of measure of variability that measure the dispersion of different values for the average value or average score. Now, variability or dispersion also means the scatter of the values in a group. That is, high variability in the distribution means that scores are widely spread and are not homogeneous. Homogeneous means not same. Low variability means that the scores are similar and homogeneous and are concentrated in the middle. Same, it means homogeneous means same. Measures of variability fall under descriptive statistics that describe how similar a set of scores are to each other. Now, the greater the similarity of the scores to each other, lower would be the measure of variability or dispersion. The less the similarity of the scores are to each other, higher will be the measure of variability or dispersion. Now, let's see the example. A teacher is interested to know the performance of two groups, A and B, of his or her students. He or she gives them a test of 40 points. The marks obtained by the students of groups A and B in the test are as follows. Marks of group A here given, that is total is 200, mean is 20. Marks of group B that here are given, n equal to 10 and total 200, mean equal to 20. The mean scores of both the groups is 20. As far as mean goes, there is no difference in the performance of the two groups. But there is a difference in the performance of two groups in terms of how each individual student varies in marks from that of the other. For instance, the test scores of group A are found to range from 5 to 38 and the test scores of group B range from 18 to 23. It means that some of the students of group A are doing very well, some are doing very poorly, and performance of some of the students is falling at the average level. On the other hand, the performance of all the students of the second group is falling within and near about the average mean, that is 20. It is evident from this that the measures of central tendency provide us incomplete picture of a set of data. It gives insufficient base for the comparison of two or more sets of scores. Thus, in addition to a measure of central tendency, we need an index of how the scores are scattered around the center of the distribution. In other words, we need a measure of dispersion or variability, as simple. A measure of central tendency is a summary of scores and a measure of dispersion is summary of the spread of scores. This is the very important point we have to remember. Central tendency, summary of scores, just summary, total divided by the number of those students. Here, measure of dispersion is summary of the spread of scores. Information about variability is often as important as that about the central tendency. Now, let's see the functions of variability used for calculating other statistics such as analysis of variance, degree of correlation, regression, etc. Now, they are used for comparing the variability in the data obtained as in the case of socio-economic status, income, education, etc. Now, to find out if the average or the mean or median or mode worked out is reliable, that is very important, reliability. Gives us an idea if the variability is adversely affecting the data and thus helps in controlling the variability. Now let's see the types of measures of dispersion or variability. The measures of variability most commonly used in psychological statistics are as follows. First one, range, then quartile deviation, average deviation or mean deviation, standard deviation, and then variance. Let's discuss one by one. First one is the range. Range can be defined as the difference between the highest and lowest score in the distribution. This is calculated by subtracting the lowest score from the highest score in the distribution. The equation is as follows. Range equal to highest score subtracted, that is minus lowest score, that is R equal to H minus L. The range is a rough measure of dispersion because it tells about the spread of the extreme scores and not the spread of any of the scores in between. For instance, the range for the distribution is given here. 4, 10, 12, 20, 25, 50 will be 50 is the largest here, highest score, and 4 is the lowest. So highest minus lowest comes the range as 46. Now range is applied in diverse areas discussed as follows. Areas where there are small fluctuations such as stock market, rate of exchange, etc. In day-to-day activities like daily sales in a grocery store, monthly wages in a factory, etc. In weather forecast like variation in temperature in a day, when the researcher is only interested in the extreme scores or total spread of the scores, range is the most useful measure of variability. When the data are too scant or too scattered to justify the use of most appropriate measure of variability. Now, second one is the quartile deviation. Since a large number of values in the data lie in the middle of the frequency distribution, a range depends on the extreme outliers of a distribution. We need another measure of variability, that is the quartile deviation. It is a measure that depends on the relatively stable central portion of a distribution. According to Garrett, the quartile deviation is half the scale distance between 75th and 25th percent in a frequency distribution. The entire data is divided into 4 equal parts and each part contains 25% of the values. Now, according to Guilford, the semi-interquartile range is the half the range of the middle 50% of the cases. Now, on the basis of above definitions, we can be said that quartile deviation is half the distance between Q1 and Q3. That is interquartile range, IQR. The range computed for the middle 50% of the distribution is the interquartile range. The upper quartile Q3 and lower quartile Q1 is used to compute IQR, that is interquartile range. This is Q3 minus Q1. And IQR is not affected by extreme values. Second one is the semi-interquartile range, that is SIQR or quartile deviation, QD we call. Half of the IQR is called as semi-interquartile range. SIQR is also called as quartile deviation or QD. Thus, QD is computed as quartile deviation equal to Q3 minus Q1 divided by 2. Thus, quartile deviation is obtained by dividing IQR by 2. Quartile deviation is an absolute measure of dispersion and is expressed in the same unit as the scores. Now, quartile deviation is closely related to the median because median is responsive to the number of scores lying below it rather than to their exact positions, and Q1 and Q3 are defined in a same manner. The median and quartile deviation have common properties here. Let's see, both median and quartile deviation are not affected by extreme values. In a symmetrical distribution, the two quartiles Q1 and Q3 are at equal distance from the median, or Q1 equal to Q3 minus median. Thus, like median, quartile deviation covers exactly 50% of observed values in the data. In normal distribution, quartile deviation is called the probable error or PE. If the distribution is open class, then quartile deviation is the only measure of variability that is responsible to compute. In asymmetric or skewed distribution, Q1 and Q3 are not equidistant from Q2 or median. In such a distribution, the median of the IQR moves towards the skewed tail. The degree and direction of skewness can be assessed from quartile deviation and the relative distance between Q1, Q2 and Q3. You can see the graph here, then you will understand easily here. Q1, here Q1, Q2, Q3. This is median, sorry, this is median. They are skewed this side and this side, extremities here. Highest and lowest skews towards right or left. So from median, both Q1, Q3 will be differing. So you understand the quartile deviation over here. Now kurtosis is proportional to quartile deviation. Smaller the quartile deviation, greater is the concentration of scores in the middle of the distribution, thus making the distribution with high peak and narrow body. The scores that are widely dispersed indicate a large quartile deviation and thus long IQR. This distribution has a low peak and broad body. You can see here illustration of kurtosis and skewness. Normal distribution will be like this. Then positive skewness will be like this, moving towards this side, and negative skewness moving towards this side. Then leptokurtic, that is normal plateaukurtic, will look like this, going down and then average and then above. So these are the kurtosis and skewness. Uses of quartile deviation, let's see quickly. The distribution contains few and very extreme scores. When the median is the measure of central tendency, when our primary interest is to determine the concentration around the median. So these are the uses of quartile deviation. The third one is the average deviation, AD, or mean deviation, MD. R and QD, that is range and quartile deviation, attempt to compute spread of values and not compute how far the values are from their average. So to measure the variation as a degree to which values within a data deviate from their mean, we use average deviation. Now let's understand first of all what is deviation. Deviation score express the location of the scores by indicating how many score points it lies above or below the mean of the distribution. That is, deviation score may be defined as X, that is mean, that is when we subtract the means from each of the raw scores, the resulting deviation score states the position of the scores relative to the mean. According to Garrett, as cited in Mangal 2002, the average deviation is the mean of the deviation of all the separate scores is a series taken from their mean. According to Guilford, average deviation can be described as an average or mean of all the deviations when the algebraic signs are not taken into the account. Now let's see, average is a central value and thus some deviations will be positive and some may be negative. Now mean deviation ignores the signs of the deviations and it considers all the deviations to be positive. This is so because the algebraic sum of all the deviations from the mean equals to 0. Now MD or AD, that is mean deviation or average deviation, is arithmetic mean of the difference of the values from the average. The average is either the arithmetic mean or the median. It is a measure of variability that takes into account the variations of all the scores in the data. It is an absolute measure of dispersion and is expressed in the same unit as the raw scores. Now the calculation of average deviation is easy, therefore it is popular measure. When we calculate average deviation, equal weight is given to each observed value and thus it indicates how far each observation lies from the mean. AD or MD can be obtained from any of the measures of central tendency, that is mean, median, mode. Mode is ill-defined, hence AD or MD is computed about the mean or median. AD or MD calculated about the median will be less than the AD or MD about the mean or mode. For a symmetrical distribution, mean deviation about mean and mean deviation about median covers 57.5% of the observations of the data. Thus, a small value of MD will indicate less variability. AD is thus somewhat larger, that is 57.5% of the cases, than QD, that is 50% of the cases. Now, let's see the use of average deviation, that is used by economists and business statisticians, used in computing the distribution of personal wealth in a community or a nation. Now, according to National Bureau of Economic Research, MD is the most practical measure of dispersion to be used for this purpose. When it is desired to weight all deviation from the mean according to their size, when the standard deviation is unduly influenced by the presence of extreme scores, distribution of the score is not near to normal. Now, the fourth one is the standard deviation, very important one. Generally, we use this a lot. The term standard deviation was first used in writing by Carl Pearson in 1894. The standard deviation of population is denoted by this symbol here, Greek letter sigma, and that for a simple sample is S. A useful property of SD is that unlike variance, it is expressed in the same unit as the data. This is most widely used method of variability. Now, the standard deviation indicates the average of distance of all the scores around the mean. It is positive square root of the mean of squared deviations of all the scores from the mean. It is positive square root of variance. It is also called as root mean square deviation. Now, let's see the definition given by Mangal. Standard deviation as the square root of the average of the squares of the deviations of each score from the mean. SD is an absolute measure of dispersion, and it is the most stable and reliable measure of variability. We use in education field this calculation a lot. Standard deviation shows how much variation there is from the mean. SD is calculated from the mean only. If standard deviation is low, it means that the data is close to the mean. A high standard deviation indicates that the data is spread out over a large range of values. Now, SD may serve as a measure of uncertainty. If you want to test the theory, or in other words, want to decide whether measurements agree with the theoretical prediction, the standard deviation provides the information. If the difference between mean and standard deviation is very large, then the theory being tested probably needs to be revised. Now, the mean with smaller standard deviation is more reliable than mean with large standard deviation. A smaller standard deviation shows the homogeneity of the data. The value of standard deviation is based on every observation in a set of data. It is the only measure of dispersion capable of algebraic treatment. Therefore, SD is used in further statistical analysis. Let's see the uses quickly of standard deviation here. Used when one requires or more reliable and accurate measure of variability, but it is recommended when the distribution is normal or near to normal. It is used when further statistics like correlation, regression, tests of significance, etc. have to be computed. Generally, we use this in our research problem. We generally test or relate. If I am taking two subjects, I will do the correlation between two. If I am taking two group of individuals, I will see the correlation between them. So, I have to use this standard deviation after calculating the mean. The fifth one is the variance. The term variance was used to describe the square of the standard deviation by R.A. Fisher in 1913. The concept of variance is of great importance in advanced work where it is possible to split the total into several parts. each attribute to one of the factors causing variations in their original series. Now what is variance here? Variance is a measure of the dispersion of a set of data points around their mean value. It is a mathematical expectation of the average squared deviations from the mean. So the variance S square or mean square MS is the arithmetic mean of the squared deviations of individual scores from their means. In other words, it is the mean of the squared deviation of scores. Now variance is expressed as V equal to standard deviation square, SD square. Now the variance and the closely related standard deviation are measures that indicate how scores are spread out in a distribution. In other words, they are measures of variability. The variance is computed as the average square deviation of each number from its mean. Now calculating the variance is an important part of many statistical applications and analysis. It is a good absolute measure of variability and is useful in computing of analysis of variance, ANOVA we call it in general, to find out the significance of differences between the sample means, whether there is a difference is there or not. Now coefficient of variation CV, the relative measure corresponding to SD is the coefficient of variation. It is a relative measure of dispersion developed by Carl Pearson. When we want to compare the variation, that is dispersion of two different series, relative measures of standard deviation must be calculated. This is known as coefficient of variation or the coefficient of standard deviation. It is defined as the standard deviation expressed as a percentage of the mean. The coefficient of variation represents the ratio of standard deviation to the mean, and it is useful statistic for comparing the degree of variation from one data series to another, even if the means are drastically different from each other. Thus, it is more suitable than SD or variance. It is given as a percentage and used to compare the consistency or variability of two or more data series. When we are taking two, then standard deviation is most apt. When we are taking two or more, then this ANOVA is very important. Coefficient of variation is important. The formula for computing coefficient of variation is as follows: V equal to 100 multiplied by sigma divided by m, where V is variance, this sigma is standard deviation, m is mean. To understand the computation with the help of an example, if the standard deviation of marks obtained by 10 students in a class test is 10 and mean is 79, then V equal to 100 multiplied by 10 divided by 79, that is equal to 1000 divided by 79, mean variation will be 12.65. So we come to the end of this session. If you like the video, please do like, share, subscribe and comment below. Thanks for your attention and time. Happy learning.